Okay, so factoring is reversing the distributive property or reversing multiplication. So if we look at just numbers, if you multiply 2 times 3 together, that equals 6. So going from the 2 times 3 to the 6, that's multiplication. Now, if we go the other way, that is called factoring. So you're splitting it up into sets of multiplication. Things multiply together, basically. And these numbers that are over here, these are called factors of 6. So something called prime factorization, which I went over, I think last week when I actually did factoring, or when I did fractions, where you're basically taking a number and you're turning it into factors, and that process is called prime factorization. You are basically factoring. You're not dividing, and so you're reversing the multiplication process basically in how it's written. You're not doing division, the inverse of multiplication. So when we have things like with variables, so let's say I have x plus 2 times x minus 5. If we want to multiply it, we're doing the FOIL process. That's actually, we're multiplying it together. And FOIL is you multiply the first terms together, x times x, which is x squared. Then we multiply the outsides, x times -5, which is minus 5x. 2 times x is the inside, so that gives us plus 2x. And then the last terms, 2 times 5 is 10. And your middle terms, you can combine those together, and this gives you x squared minus 3x plus 10. So we FOILed to go from the multiplied form to our form right here. So that's the FOIL process. And then when you have a trinomial, like something on the right, and you are turning it into what's on the left, that is factoring. So you're taking a polynomial and you're writing it as a series of ideally binomials multiplied together. We go on a series of terms multiplied together, and that's called factoring. So there are multiple ways to factor. Most of the time we're factoring something that is considered a trinomial, where you have x squared plus something x plus a number, or you might have a number in front of the x squared term. But those are the most common things that we are doing when we are factoring. Another type of factoring, if you don't have like a term times a term where you can FOIL, is you could have, let me do this in black. You could have multiple variables, or you just have something in front and you need to multiply it by through the parentheses or whatever you get here. So I'm just kind of making this up. So you're distributing. So when you're doing the distributive property, you're taking the 2a and multiplying it by 3b squared. So 2 times 3 is 6, and then ab squared. Then you take that 2a and you multiply it by ab. So that's going to be 2, you get a squared b. And then you'll take the last term, you're taking 2a times that minus 4c. So that gives you minus 8ac. So that is distributing. And when you go the other way, to turn it back into the original, again, that is called factoring, but this is particularly called factoring out the greatest common factor. The GCF is how we abbreviate it. That there's something in common that you can divide out of every term, and you put that in front, and then the remainder is in parentheses. So that is what factoring is as a concept, basically, is you're undoing multiplication. And the reason why we do this is because it's often easier to simplify things, cancel things out if you have a fraction, or that's usually most of what we do with factoring. When we're solving equations, it's often easier to solve in factored form than multiplied out. So that's one thing we do, is we solve by factoring. Factoring shows up a lot. It makes a lot of problems easier. And so it's a good skill. So yeah, I can go through the factoring process. I'm going to want to open up a textbook or something, because if I make up a problem, it's very likely that it's not going to be something we can factor. So I want to make sure that I have something that deliberately can be factored. So I'm just opening it up right now. There's so many things to click to get to the textbook. And I have more things to click than you guys do, because I don't go straight into Alex. I have to go in a different way. Okay. So let's do this in black. Let's say you are told to factor 8a squared b cubed plus 12a squared b. So in order to factor this, the first thing you always do is determine the GCF, the greatest common factor. That is number one, first step. And the greatest common factor is, first, when you're looking at the numbers in each term, you're looking for the biggest number you can divide evenly into the numbers you've got. So out of 8 and 12, 4 is the largest number that divides into both. So my greatest common factor is going to have a 4. Then you look at your variables, and you look at each letter one by one. So I've got a, and I've got an a squared in both terms. So since a squared is in both terms, that means I can take it out of both terms. So that's going to be part of my greatest common factor. And then I move on to the letter b. So I have b cubed, and then I have b. So if they don't have the same exponent, your greatest common factor is going to contain the smallest exponent. So that would be just a single b that has no exponent on at all. So that is your greatest common factor. So once you identify that, then you actually do the factoring process. And that process is, I usually write it as you have your GCF in front, And then you take each term and you divide it by your greatest common factor. And you would just keep going. So if there's 3 terms, you would divide each of them by your greatest common factor. And then you simplify what's inside. So our greatest common factor is 4a squared b. And so my first term is 8a squared b cubed. So I divide that by 4a squared b. And my second term is 12a squared b. And we divide that by 4a squared b. And then you simplify the inside of the parentheses. So you're going to do the division. This is basically, we've created exponential expressions, which is why that homework comes before the factoring homework. Because you need to be able to simplify an exponential expression in order to do the factoring. So I still have 4a squared b in front, and then I start simplifying. So 8 divided by 4 is 2. The a squareds completely cancel out. So those are just completely wiped out. And then I have a b cubed over b, which you can think of as having an exponent of 1. And in order to simplify those, you subtract the exponents top minus bottom. So 3 minus 1 is 2. So I'm going to be left with a b squared. Then I have my plus. Then 12 divided by 4 is 3. Again, my a squareds completely cancel out. And here the b's also cancel out. So I only have that 3 left. And that is your answer, because once you've simplified that, then that is the factored form. So for this example, we basically undid the distributive property by factoring, as we pulled out the common factor that was multiplied through the parentheses. So that goes in front, and then whatever's left over is in the parentheses afterwards. Now it's a different process if you have something with multiple terms. So usually if we have 4 terms, we do something that is called factor by grouping. So there's different types of factoring. Factoring out the greatest common factor, factoring by grouping, factoring trinomials. So let's see, I'll just move this up. So let's say if we want to factor by grouping, let's see, 4x squared plus 6xy minus 2xy minus 3y squared. So we factor by grouping when there's 4 terms. First step is always to factor out the greatest common factor if possible. That's the first thing that we always do. So first you want to see, is there a GCF? So if we're finding the greatest common factor with 4 terms, with the numbers, I need a number that I can divide into 4, 6, 2, and 3. All 4 of those need to have a number in common. Now, unfortunately, there isn't a single number I can divide out of all 4. I can divide 2 out of 4, 6, and 2, but I can't divide 2 into 3 and get a whole number. I can divide 3 into 6, but it doesn't go into 4 and 2. So there's no number there. And then if you look at the variables, in order to factor it out, you need the same letter in every term. So I have x in only 3 of the terms and y in only 3 of the terms. So if there's nothing in common here, there's nothing to factor out, and the GCF is just 1. And if it's 1, then we don't need to factor it out. So there's nothing to factor out. So sometimes you can't factor it out because sometimes there isn't one. So in this case, we couldn't. So step 2 is what we do, what we call grouping. And that's where you take the first 2 things together and you put parentheses around them. And then the second 2 things together, you put parentheses around them. So we're grouping it together, and I keep picking the wrong blue. I want the darker blue. So you're grouping them together in pairs. And this is using the associative property, which allows you to group things that are added together. Now, the third term is a negative, a minus 2xy. And whenever you're grouping, you always need to have a plus in between. So I'm turning that minus into plus a negative so that I can make sure that I have a plus in between those 2 groups. So I've grouped the first 2 things together and the last 2 things together. And then what you do is you find the GCF of each group. So we're going to have 2 different greatest common factors because we've got 2 different groups. They're not going to match. So for the first pair, I'm only looking for a number that I can divide into 4 and 6. So 2 goes into both. And then I have an x squared and an x. So with variables, you pick the smallest exponent, which would be an x. And then because I don't have a y in the first term, I can't factor out a y. So the GCF does not contain a y. And then I move on to the second group that we have. So I'm looking at the numbers, -2 and -3. So out of 2 and 3, I can't divide a number out of both of those. So normally I would just write a 1. But if the first term is negative, we always factor out a negative, because if we don't, it's not going to work. So I'm going to use a greatest common factor of -1 instead of just 1. Then I have my first term having x, but there's no x in the second term, so I can't factor out an x. And then I have a y and a y squared. So the y doesn't have an exponent, so that's what's going to go into my GCF. So once you find the greatest common factor, then you factor each group. So we're basically taking what we did in this example and we're doing it twice because we have 2 sets of groups together here. So I have 2x because that's the first GCF, and then I divide each term by that greatest common factor. Then I have my plus sign. Then I write my second GCF and divide each term by that. And instead of that minus 3y squared, I'm going to put a plus and put that negative in the fraction. So that way you can see that it's going to be a negative divided by negative there. So I have a 2x. Now I'm going to simplify. So in the beginning here, I have a 4x squared over 2x. 4 divided by 2 is 2. And x squared divided by x is another x. So that would be subtracting exponents 2 minus 1. Then we have 6 divided by 2, which is 3. These x's completely cancel out. And then I have a y. So I get 2x plus 3y. Then I have my -1y. And then a -2 divided by -1 is a +2. And I have an x, but the y's completely cancel. Then I have a -3 divided by a -1, so that's a +3. And with the y's, y squared over y leaves me with a single y left over. So now I've factored each group, and you may notice that in parentheses, I have the same thing, 2x plus 3y. When that happens, that means you are on the right track. That means you've done everything correctly here. If it doesn't match, which usually is because maybe you made a math error or you didn't take out a negative when you needed to, if they don't quite match, that's an indication you have an error somewhere. Because these should match. So at this point, once you have them match, you're going to factor again. Factor out the matching term. There. So we're basically taking that 2x plus 3y and we're factoring out again. So that is now our GCF because that matches. And then you take each term, which we have two terms here, and then you're dividing out that 2x plus 3y. So it's kind of like we're doing the process a second time. Because we really are, we're factoring out multiple times. And what happens is the parentheses, the term basically in both sets just completely cancels out. And so you're left with 2x plus 3y. And then we have a 2x plus -1y. Or we usually would just write this as 2x plus 3y times 2x minus y. So that's factoring by grouping. You started with something that has 4 terms. And we are factoring multiple times, but we're doing it in little sections. So we grouped each of them in pairs, factored each pair because they had something in common. And then we found something in common again, so we factored again. Now the trick with factoring by grouping is that I usually don't show this step right here. I usually just go from the step before to this step on the bottom because I notice a pattern, and this is a pattern that will happen every time, is what's in parentheses will always end up in front, and then you'll have a second set of parentheses, and that comes from the GCFs, your 2x and your -1y. So that's a pattern that shows up every time, so I usually don't even write that step with the arrow because I just notice the pattern and I know what it's going to look like. So that's factoring by grouping, and that's the process. That's the steps that you do every time when you're factoring by grouping, and you do it when you have 4 terms. So next type of factoring is factoring trinomials. I'm glad that this answer, so I'm really glad that this helps. Now, factoring, you're going to be doing it pretty much every single week. So if you can get this down and be fast at it, you're going to save yourself so much time because you are going to be factoring all the time, all the time. So next part that you cover then is factoring trinomials, and trinomials are of the form ax squared plus bx plus c. You could have some negatives in there, but basically you have something squared, you have something not squared, and then you have a term with just a number. And this is the type of factoring that you do most of the time, is factoring trinomials. So there are multiple methods. There is what the book calls trial and error, or guess and check. And then there's also the AC method. So the AC method is what I recommend if you have a number in front of the x squared. So if there's something in front of the x squared, I usually use the AC method unless the numbers are small enough that I can do guess and check quickly. If it's a prime number in front of the x squared term, then I usually do guess and check because there's only one possible way to multiply to that. But basically, the trinomial is you're trying to undo your FOIL, where you have something in front of each x, and then you have something in the end. And the first terms need to multiply to a. The last terms multiply to c. And then the combination of the two terms adds to b. So you're asking yourself, what two numbers multiply to a? What two numbers multiply to c? And how do I make that combination work so that when I FOIL, it gets me back to where I started? So that's sort of the thought process behind factoring a trinomial by guessing and checking. If there's not a lot of ways to multiply to a or to multiply to c, it goes pretty quickly. Now, the AC method still has some guessing and checking, but there's less of it and it's easier. So it's more steps to write out, but you don't have to think so hard and go through every different possible combination. So we're going to factor using the AC method. And often I'll say we are factoring by grouping because that's essentially what we are going to do. Is we don't have 4 things to do grouping, so we force it to have 4 things, and then we do the grouping process. So let's find a good one that we can do by grouping. Okay, so here's one that we would do grouping on. 16y squared plus 14y plus 3. Or the AC method. So as always, you always want to find the greatest common factor. Because if there's a number that I can divide out of here to make my number smaller, I want to do so. In this case, 3 doesn't go into 16 or 14. So like the last one, our GCF is 1, and so we're not going to factor it out. So I'm going to just make a note, factor out if possible. Factoring out of 1 is not going to do anything. So to do the AC method, step 2 is to find A times C. So you're literally taking your A part and multiplying it by, the C part. That's why it's called the AC method, is because you're multiplying A and C together. So 16 times 3, I want to say that's 48, but I'm not, no, that's not right. Maybe that is right. Yep, 48. I don't have to do that multiplication too often. So you literally multiply those together and find that number. So once you find AC, then you want to write down all pairs of numbers. Abbreviate numbers. that multiply to AC. We're writing down basically all of the factors. So this is going back to very beginning here. So 2 and 3 are factors of 6, but those aren't the only factors because 1 times 6 also gets me 6. So you're going to write down every possible combination that multiplies, and you're doing it specifically in pairs. So this is the part where you end up having to do some sort of guessing, because you have to kind of figure out what numbers multiply to this value. And but this is the hardest part, basically, is to write down all of your pairs. So I usually just start with 1. So I know to get to 48, I'd have to multiply 1 by 48 in order for that to equal 48. So then I just keep counting up on the left. So I do 2. 2 times what gets me 48? So that's 24. We know 3 times 16 gets you to 48. So then I look at 4, and that's 4 times 12. And if you're not sure, all you have to do is do 48 divided by 4, and then that gets you the matching number. So like if you're looking for 5, 48 divided by 5 gives you a decimal. So we're not going to write that because we want only whole numbers here. So then we try 48 divided by 6, which I'm pretty sure that's 8, but for whatever reason, I'm not trusting myself for whatever reason. And then we would try 7. And then once you get to 8, you've kind of come around in a circle because you have 8 written down already. So you don't have to try every single possible number. You just keep trying numbers until you've kind of come in a circle and you have a number that's already written down. So these are all the numbers that multiply to A times C. So once you've written that down, you want to find the pair that adds to B. So I want to find the pair that adds to the middle number 14. So like a 1 plus 48, that gives me 49. That does not add to 14. 2 plus 24 is 26. 3 plus 16 is 18. 4 plus 12 is 16. 6 plus 8 gets me 14. So our pair of numbers are 6 and 8. And this process, steps 3 and 4 here, are the same thing you do when you do guess and check. Is you're going to look for all the numbers that multiply to something and then add up to something else. So once you find your pair, you rewrite the middle term. Using those values. So instead of writing we had in the middle 14y, we can write that as 6y plus 8y. Because 6y plus 8y equals 14. Now there's lots of ways to add to 14, but we have to do it in such a way that they have numbers in common with 16 and 3, those outside things, so that we can factor by grouping. Because we have to make sure we can divide something out. So that's why we have to first multiply to those numbers so we can find something in common that we can factor out. So it's not just any old combination to get to that middle term. It has to be specifically done this way. So then once you've identified that, you factor by grouping. So we have 16y squared, and instead of writing plus 14y, I'm going to have plus 6y plus 8y plus 3. And so then from here, now you're doing the grouping process. And so this is why I usually just say, instead of using the AC method, I'll say we're factoring by grouping, because we are. We just have to do a little manipulation in the beginning so that we can do this. So now that I've set up my groups, I'm going to find the GCF of each group. So the first pair, I have 16 and 6. So I can't divide 6 into 16. I can't divide 3 into 16, but I can divide 2 into 16, and it also goes into 6. And then I have a y squared and a y, so you take the smallest, which is y, because there's only one of them. Second pair, 8 and 3 don't have anything in common. There's no number in common, so I'm going to write a 1. And then I have a y, but I have something without a y, so I can't even take out a y. So I just literally have my GCF there, and it's just a 1. So now the next step is to write your GCF in front, and then to divide each term by the GCF. So you have to make sure not to get these two confused, and then I have to have a plus sign in the middle. 1, and then I'm literally just dividing these by 1, which is kind of silly, but I'm showing the steps so that you can see the process. So then I've got 2y. Now I have 16 divided by 2 is 8. Y squared over y. I have a y left over when I divide out a y. 6 divided by 2 is 3. And these y's cancel out. I have 8y plus 3. Then I have my plus 1, and then you divide by 1 and you get 8y plus 3. So we have the same thing in parentheses here, which means we've done this correctly. So then I usually just go to my final step where that's in front, 8y plus 3. And then whatever the GCFs are is the second part. So that's 2y plus 1. So that is the AC method. If you can factor by grouping, it's pretty simple. The hardest part is probably just finding the greatest common factor, and it's usually not too bad. And then you just have to do some division. But to get to that factor by grouping part, you have to make sure that you find all of your pairs. You have to multiply A times C, and then find the correct pair so that you can rewrite that middle term. So that's the hard part, where you have to kind of do some guessing. When you get good enough at it, you don't have to write down every pair, because you can kind of think in your head and figure out what pair it is. So you want to do enough practice, and really, in order to get quick at this, you need to know your multiplication tables, because then you're not sitting there on a calculator trying to divide until you find the right number. If you know your multiplication tables, then you can just kind of do it in your head, and you don't have to show all this work, and you can go straight there. So that's the goal, is to be really good at multiplication, really know your division, so you know what numbers divide into other numbers, because it will make your life so much easier. So that is the AC method to factoring trinomials. And then the last method is guessing and checking, or trial and error. So factor by trial and error, or guess and check. And I recommend doing this only for things that don't have a number in front. So if it's only x squared plus bx plus c, and you don't have that number, because it's just, sometimes it can get a lot of work to try to do it the other way, and it's just faster to do grouping. So an example of this is, let's see, if instead of bx it was 2x, and then plus 15. So the way guess and check works is that you basically set up the end game. I know that I'm going to be reversing FOIL. And with guess and check, with no number in front of the x squared, you know that you have to have an x in front of each term, because x times x gets you x squared. So this is going back up to this on the right, where the first parts multiply to a, the last parts multiply to c, and then we need to add to some combination in the middle. So, and if everything is positive, then you know you're going to have plus signs here. And all you need to figure out is these two numbers. And those two numbers, they multiply to 15, but they need to add to 2. So actually, you know, I'm looking at this. This is prime, but if I make this a minus 15, it will not be. So we'll do that because we want to make something we can actually factor. So we need to now multiply to a negative 15 and then add to 2 in order for this to work. Now, if you're multiplying to a negative, one of the numbers has to be positive, one of them has to be negative, because 2 negatives make a positive, 2 positives is a positive. So you have to have opposite signs in order for this to work. So just like here, where we had to write down all the pairs that multiply to 8 times c, we're going to want to write down all of the numbers that multiply to 15. So like 1 times 15, 2 doesn't go into it, 3 times 5, and those are the only choices. So this is why it's a good way to, good method with guessing and check here, because you don't have a lot of choices to pick. So these are the only things that multiply to 15. 1 times 15, 3 times 5, and we need to have opposite signs, and we need them to add to a positive 2. So if you have opposite signs, they're adding to a positive. The second number, the bigger of the two pairs, is always going to be positive. And then the smaller of the two pairs is going to be negative, because that's the only way to add to a positive. If you're adding to a negative, it's the reversed. The bigger is negative, the smaller is positive. So that kind of helps determine the signs that you have here. So if we add these, negative 1 plus 15 is 14. That doesn't work. The negative 3 plus 5, that gives you 2. So then all you need to do is plug in your numbers that you found, your pair, negative 3 and 5. And that's your answer. So we have x minus 3, x plus 5. And that's factoring by trial and error, guess and check, as you do have to do some guessing on what pairs work. But once you find the pair, you just literally stick them in the form. So once so again, if you know your multiplication tables and something like this, like I can do it in my head because I know the combinations there's only 2 possible choices, and I can figure out what the signs are pretty easily in my head. So that's factored by trial and error or guess and check. And that's why I would use this for something like x squared plus 2x minus 15, is you don't have a lot of choices. It's pretty simple. And if none of your choices work, either you have an error or that means it's prime. It can't be factored. Now, an example where I would not use trial and error would be this one right here. And because when you factor something where you have a number in front, you have lots of possibilities. Because not only, and I'll do this in purple, as if I was trying to factor by guessing and checking 14y plus 3. I'm going to have something times y plus something. Something times y plus something. So, let's see. I don't want to mix up my colors here. Things in front of y need to multiply to 16. And so your choices are 1 times 16, 2 times 8, 3, 4 times 4. The back parts need to multiply to 3, because this is kind of following this shape here. We have the foil part. Now, luckily, there's only one choice that multiplies to 3, 1 times 3. So you've got 4 things to test here, but the tricky part is that these inside portions, these need to add to 14. And the trick is, now you're not just multiplying and adding 2 sets of numbers. Now you have to find some combination of these. Like I could have 1 times 16, 1 times 3, but I could also instead put the 3 times 1 here, and I'd get a different number. And then if that doesn't work, you have to go to the next pair. Oops, I removed too much. 2 times 8, 1 times 3. See if that works, which actually the middle would give me 8. 9 plus 8, nope, that's 17. That doesn't work. So if that doesn't work, then you have to change 3 times, you know. yeah. This takes forever. This is why I don't do this, because the AC method, while you do have to do some guessing, it's much simpler than having to try every single possibility here. And let's see, the 4 times 4, 1 times 3, 4 times 3 is 12. So, man, I might have missed it here, because I know we factored. What do we get? What was the actual 8, 3, 2, and 1? Okay. So 8 times 2 gives me 16. And then let's see. So I have to think, if I did this 8 times 3, nope, that doesn't work. 3, 8 plus 6. There we go. That's how we get the 14. So if you're not careful, if you don't put them in the right spot, you know, you can flip-flop them. There's just a lot of combinations, and it's much harder than, while the AC method is lengthy, there's less guessing and checking going on, and you're not going to make as many mistakes. But guessing and checking on something where you don't have a number in the front is relatively simple. So that's why I only recommend it if there's no number in front, because you don't have as many possibilities. So that is factoring in a nutshell. That basically, you know, I basically broke down every single type of factoring that you're going to be seeing. And seriously, factoring, if you're not good at it, can take you a long time and waste time on the quiz. And what makes it quicker is lots of practice and knowing your times tables and being able to divide, because then you don't spend as much time trying to figure out what numbers go together. Or at least have a calculator handy, you know, just start spitting out numbers. But if you need to do flashcards for multiplication tables, that would be a good way to speed up your factoring, because if you can speed up your factoring, then you'll have no problems with time on the quizzes, because that's usually where people run out of time, is they usually spend too much time on the factoring. So you really want to get quick on the factoring. And if you do enough factoring, you start to memorize what these look like, because you'll see the same ones pop up over and over again. And so you'll just memorize how they factor. And so then you don't even need to do the thinking. You see it and you're like, oh, I know this factors. Like, for example, if I see something like x squared minus 4, I just know immediately how that factors. And I have that memorized, and I don't have to think about it. And it takes like 2 seconds. So that's where you want to get. And you're not going to be there immediately, but with lots of practice, you can get there, and with good multiplication tables. So I'm glad this has made you feel better about factoring. This is like 2 sections that I just went over in an hour. I usually like to do more than one example, but this is a good overview of all the steps. I will email, so I've been recording this. I will email it out tomorrow because I'll upload it to YouTube. And what I'm going to do is save this OneNote as a PDF. So that way you have access to this and you can have like basically the steps in your notes so that you know, okay, factoring. And the basic rule is, well, how do I know which method to use? Try it in this order, basically. If there's a GCF and then you have something with a quadratic, try to factor more. If it doesn't work, okay, then you're done. Factor by grouping, only 4 terms. So that one is pretty simple. If it doesn't look like this with 4 things, then don't do this method. Trinomials always look like this. So if you see 3 things like this, just always do this. So it's kind of like, does it fit into one of these buckets? And then if it does, that's what you try to do. So, and if you do enough practice, you'll kind of get used to which ones to do. So.